This is exercise 1, vector in series. Okay, you have two CSTR in series. The question is, what are the volumes for each vector? Please compare with using only one CSTR with a final conversion of 0.8. So final answer is given here, and then you are given at x equal to 0.4, 1 over negative RA is 250, and x equal to 0.8, 1 over negative RA equal to 800 liter per minute per mole. Okay, so you are given FA naught. So you are given FA naught. The conversion after the first vector is 0.4, and the conversion after the second vector is 0.8. And you are also given the plot. Okay, so basically this is CSTR. As usual, you need to know what is the design equation for CSTR. So by now you should, obviously you need to derive it from mole balance, general mole balance equation, but I'll skip that part because that is your task to come up with the design equation. So we just start with the design equation for general design equation for CSTR. That is V is equal to Fa naught minus Fa divided by negative RA. Okay, then this one can be simplified, having Fa is equal to Fa naught 1 minus x. You may have Fa naught So this is for the first vector. So I'll put it V1, x1, negative RA, 1. Okay. Then if you look at for volume for vector 2, it will be Fa1 minus Fa2 divided by negative RA2. Okay, so if you represent it in this graph, so it is a box, yeah, it's a box. Okay, this one also can be further simplified. Okay, I hope you agree. You agree with this equation. Fa1 is equal to Fa naught 1 minus x1. Fa2 is equal to Fa naught 1 minus x2. Okay. So if you expand this formula, so I'll put it here. I'll expand it, so Fa naught x1 minus Fa naught plus Fa naught x2 RA. So this one you may cancel out, and then you may have Fa naught. So I'll put this one in front, so it will be Fa naught x2 minus x1, negative RA2. Right. Okay, so what are the information given here that we can use to solve the problem? So before that, let's plot the graph. So if you look at this is 0.4, so it is a box. So basically you need to find the volume here, volume of box, and then you may also have for the second vector from 0.8. So this is CSR number 2. Okay, this is number 1. Right. So basically you may solve for V1 is equal to FA0 divided by negative RA. So FA0 is given here, it is 50 mole per minute divided by, so negative RE1. Negative RE1 is when your x is 0.4. So this will be your 1 over negative RE1. Okay, so this is RE for 1. This is RE for 2. Okay, so since it's given 1 over negative RE, you can just multiply. Okay, multiply. So multiply will be, so I should delete this line. I'll put this one. And your x is punch your calculator. So V1 will be equal to 5000 liter. And then for V2, again it is FA0 per minute. And then 1 over negative RE2 is at 0.8 is 800. Multiply by x2 minus x1. So 0.8 minus 0.4 will be again 0.4. Then punch your calculator. It is 16,000 liter. Okay, let me cancel out the units lah. Okay. Alright. And then you already calculate volume for each reactor. Then please compare with using only one CSTR. So if it is one CSTR, meaning that you are going to use this formula. This formula. So if one single CSTR, so it will be FA0 x1 divided by negative RE1. Okay, so here your FA0 remains similar, mole per minute divided by x1 now is one single reactor, it will be 0.8. So 1 over negative RA, because this is 1 over negative RA, so it is 800. 800 liter per minute mole. So punch your calculator. See this, 30,000 liter. So if you want to plot it on the graph, it will be a big, okay, a big box. So it's basically 800 times 0.8. Okay, and then you need to multiply with the F0. If you just multiply 800 at 100 multiplied by 0.8 is only formula for 1 over negative RE times X. So you don't have F0 here, so you need to multiply with F0 if you are calculating the area from the graph. Okay, so basically that is exercise number 1. And I hope it's clear. So you may try assuming the reactor is PFR, but still using the same plot also can. So it is area under the curve, for which you need to use the numerical methods. Okay, that's all for exercise 1, chapter 5.